Hello, let's go on to section 2.6, which is the chain rule and the generalized power rule. First thing we want to look at is composition of functions. So if I have f of x equals x squared, g of x is 4 minus x, find f of g of x. So this should be a review. That's f of 4 minus x. So every time I see a x, the x variable in f of x, I'm going to plug in 4 minus x. That's 4 minus x quantity squared, and we can FOIL that out. Square the first thing, multiply these two together and double it, and then square the last thing. Okay? And then g of f of x is g of x squared. So that's going to be 4 minus whatever's inside here, which is x squared. Okay. So think about inner function and outer function. We'll need that for the chain rule. Okay. Now to the opposite, I give you the resulting function f of g of x, and you need to find x squared plus 1 to the fifth. Okay, and break that down. So the inner function is g of x, and the inner function here is x squared plus 1. So x squared plus 1 is g of x, and that means that f of x is the outer function, which is something raised to the fifth. So x to the fifth. Okay. Now what the chain rule tells you is if you have a composition of functions like this, you're going to take the derivative of the outer function, leave the inner function alone, times the derivative of the inner function. Okay? So let's do an example. So this one, my outer function is a product, so a power, so I'm going to bring the 10 out front, minus 1. So I get 10, and then leave the inner function alone, raised to the 9th, multiplied by the inside, which is 2x minus 5. Okay? So we brought the 10 outside, left the inside alone, raised to the 9th, times the derivative of the inside. Okay, that's what this tells us here, times the derivative of the inside. Then we can combine. What we can do is we can write it like this: 10 times 2x minus 5 times this guy, raised to the 9th power. And then if you wanted to, you could combine these and get 20x minus 50 times this thing raised to the 9th power. Okay? Either of those answers is acceptable. So basically what we've just done is the generalized power rule, which is nothing more than the chain rule applied to powers. Okay? So if you memorize the chain rule or know how to use it, that is good. Okay? This is just a special application of it, what we did above. Let's look at this one. So this is x to the 4th minus 2x squared minus 2 raised to this 1/2, right? That's square root. So again, the 1/2 is going to come out front. I do minus 1. So that's going to be 1/2. Leave the inside alone. Raised to the 1/2 minus 1 is negative 1/2. Times the derivative of the inside, which is 4x cubed minus 4x. Okay? And again, we can combine this or rewrite it using radicals. So our original function is, our question is in radical notation, so our answer should also be in radical notation. So you want the format of the answer to match the format of the question. So what I'm going to do is move the 1/2 out here, right? So it's 4x cubed, and then let me pull out a 4, minus x, times a 1/2, which is the same thing as divided by 2. And then this guy, this big thing, is raised to the negative 1/2. The negative pulls it down, and then the 1/2 makes it a square root. Okay. We get 4 over 2 is 2 on the top. So you get 2 x cubed minus x over, oops, no more 2 on the bottom. And then the square root that is the final answer. Let's do some more. 1 over x squared plus 1. So if you look at this, you might think quotient rule, but actually you can use the chain rule to do this. It's even better. That's x squared plus 1 raised to the negative 1. Okay, so that makes it so easy because the negative 1 comes out front. Leave the inside alone. Raised to the negative 1 minus 1, which is negative 2. Times the derivative of the inside, which is 2x. Okay. Then we can multiply the negative 1 and the 2x, and then again leave the inside alone. Oh, it's to the negative 2 power. So let me go ahead and put that at the bottom then. Divided by x squared plus 1 raised to the second power. Okay. How about this one? This is the derivative of x squared plus 1 raised to the negative 3. Okay. How is that working? Well, this is 1 cubed over x squared plus 1 cubed. That's 1 over x squared plus 1 to the third. So we're going to bring the negative 3 on the outside. X squared plus 1 raised to the negative 4. Negative 3 minus 1 is 4. Times the derivative of the inside, which is 2x. Then you multiply negative 3 by 2x, you get negative 6x over x squared plus 1 raised to the 4th power. Okay. Let's look at this one. An oil tanker hits a reef, and after t days, the radius of the oil slick is given by this function. How fast is the radius of the oil slick expanding after 2 days? How fast, right? Rate of change. So that tells you derivative. Okay? So we need to take the derivative of the, how fast is the radius? So the derivative of the radius. So that's r of t. So we need to find r prime of t. Oops. So let me write down r of t first. So that is 4t plus 1 raised to the 1/2. Then r prime of t is 1/2 times, leave the inside alone, raised to the negative 1/2 times the derivative of the inside, which is 4. Okay? And then we can multiply the 4 by 1/2 and get 2 divided by square root of 4t plus 1. Okay? And they want to know how fast is the radius expanding after 2 days. So when we plug 2, that is 4 times 2 is 8 plus 1 is 9, square root of 9 is 3, so that is 2/3 of a mile. So expanding 2/3 of a mile per day after 2 days. Okay. Let's look at some of these problems. These are using more than one rule. Okay. So here you can see I have a function raised to a power, function raised to a power. So now I have to use chain rule. So this is chain rule. But I also have the two things multiplied together, so that is also product rule. Okay. Now question is, which one do you do first, the chain rule or the product rule? Well, look at the entire function. The entire function is a product, right? So you're going to do the product first. And then within the product rule, you're going to do the chain rule. Okay? So let me write all the pieces out. Okay, and it helps to organize like this. 5x minus 2 raised to the 4th. That is f of x. And then g of x is the second one, 9x plus 2 raised to the 7th. Okay? And then f prime, the derivative of this is 4. Now we have to use a chain rule here. The 4 comes out front. leave the inside alone, raised to the third power, times the derivative of the inside, which is 5. So then this becomes 5 times 4, which is 20, 5x minus 2 raised to the third. Okay? And then g prime is the 7 comes out. So again, chain rule. 7 comes out, leave the inside alone, raised to the 6th, and then multiply times the derivative of the inside, which is 63, 9x plus 2 to the 6th. Okay, so 9 times 7 is, 63. 63. Okay. Now we can put all this together. So we want f prime g plus g prime f. Remember the product rule? So that is going to be f prime is this 20 times 5x minus 2 raised to the third times g. G is 9x plus 2 raised to the 7th plus g prime is here 63 9x plus 2 raised to the 6th, and then f is 5x minus 2 raised to the 4th. Okay? Now that is it. I think that is our final answer. Because there's no way we can combine any of this, right? Okay, so we have our final answer here. Let's go to the next one. Now this one is, you could do this in multiple ways. You could look at this as, so we don't have to use a function raised to a power. So we know we might have to use the chain rule. And also it's a quotient, so we know we have to use the quotient rule. Okay? So let's see. You could also write this like this. D over dx, x to the 4th over x plus 1 raised to the 4th. Okay? So if you do it this way, I think it'll be a little bit easier. You can use a quotient rule, and then within the quotient rule you have to use a chain rule. This one, here I'll do it both ways. Let's look at this. So let's look at this part first. So the chain rule, so the 4 comes out front, and then leave the inside alone, and then raise that to the third power, and then the derivative of the inside. For the derivative of the inside, we have to use the chain rule. So it's the derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. Okay, so that is the quotient rule. Now we need to combine, so I'm going to write this as 4, and I'll distribute that. This is x cubed, x plus 1 cubed. Remember, when you have a fraction, you can distribute the exponent. This becomes x plus 1 minus x, so it just becomes 1 over x plus 1 squared. Okay, and then look at this. This simplifies to 4x cubed over x plus 1 to the 5th. Right? These two can combine. So that's one way of doing this problem. The other method is this way. So since this whole thing is a quotient, we're going to use the quotient rule first. So we have the derivative of the top times the bottom minus derivative of the bottom times the top. Now what did I do here? All over the bottom squared. So whoops, x plus 1 to the 4th squared is x plus 1 to the 8th. So when we did here minus derivative of the bottom, the 4 comes out front, leave the x plus 1 alone, raised to the third power, times the derivative of the inside, which is just 1. Okay? Should just be 1. So now we can combine like terms. So let's see, we get 4x cubed here and 4x to the 4th here. So what can I pull out? Let's see, I can factor out a 4 and an x to the 3rd and an x plus 1 to the 3rd. Then on the inside I have so x plus 1 is left on this side, minus an x divided by x plus 1 to the 8th. Okay. So again, here I've pulled out a 4x cubed times x plus 1 to the 4th. So we pulled out 3 of the x plus 1s, we pulled out a 4, we pulled out an x cubed, and this is what we have remaining on the inside. You can distribute this and check if you would like to. Okay. And then the x plus 1 to the 3rd divided by x plus 1 to the 5th, or to the 8th rather, gives me x plus 1 to the 5th on the bottom, right? 3 minus 8 is negative 5. And then here this becomes 4x to the 3rd. And here the x minus x are gone, so you're left with just 1, so multiplied by 1. So as you can see, either way you get the same answer. Now you can decide and for yourself which way you like better. Okay. Okay, let's do this one. So now be careful, the derivative of y. So before my variable was x, now I have to write y. The only thing is, it's no different except what you write. Okay. So let's see, the 5, I'm going to pull out front. So I get, whoops. So I get 5, and then leave the inside alone. Raised to the 3rd times the derivative of the inside. What's the derivative of the inside? Well, that's 2y. Oh, and then all of this is being raised to the 4th. So the 5y squared plus y squared to the 3rd raised to the 4th. Okay? And then times the derivative of the inside, which is 2y plus, now the 3 comes out front. You get y squared minus 1 raised to the 2nd times the derivative of this inside, which is 2y. Okay? So there are chain rule inside chain rule. It's like multiple composition functions nested. Okay? So let's see, how can we simplify this? Well, we can leave the 5 alone, and then we have, whoops, something's happening. Okay. We have y squared plus y squared minus 1 raised to the 3rd raised to the 4th. I don't think there's anything we can do there algebraically. And then times 2y plus 3 y squared minus 1 squared, and then the 3 and the 2y can combine, so we get 6y. Okay. And then if you wanted to, you could distribute that 5 inside here and call this 10y and 30y, but this answer is also fine. Both of these answers are good. Okay. Alright, so another way to write derivative is to write it as dy dx. Okay. So when I say dy dx, it means take the derivative of this with respect to x. So x is your variable. Okay, the letter in the denominator is the variable. So let's do this. We're going to bring the 5 on the outside. Again, chain rule, leave the inside alone. Raised to the 4th power. Okay. And then times the derivative of the inside. For that you have to use the product rule. Derivative of the 1st times the 2nd plus derivative of the 2nd times the 1st. Okay. So f prime g minus or plus g prime f. So what am I calling f? Here's f, here's g. Okay, that is just to do the derivative of the inside. Okay. And another easier way to do this is to FOIL this first, so you don't have to use the product rule. So if you wrote it as d over dy of x to the 4th minus x squared raised to the 5th, then again you bring the 5 out front, Leave the inside alone. Raise to the fourth. Now you do times the derivative of the inside. 4x cubed minus 2x. Okay? Now if you check these, you'll see that they are both equivalent. It's just you cannot do x squared times x squared put minus 1 to the fourth that quickly. It'll take some time. And then this becomes 2x to the third. Okay. Alright, so that is all of 2.6. If you have any questions, please come see me. Thank you for watching.